Hello. Today's video tutorial is going to demonstrate effortless strategies to automatically import CSV data into BigQuery. Our key focus will be on two primary methods, the BigQuery transfer service and cloud functions. Regardless of the pathway you choose, the transfer into BigQuery is fully automated, sourcing data straight from Google Cloud Storage. Here's a peek into our approach. We start by transmitting our CSV data to cloud storage. With zero requirement for human intervention, one of these two amazing services swings into action, conducting the transfer into BigQuery. Throughout this tutorial, we'll delve into the pros and cons of both methods, allowing you to select the one that's the right fit for your specific requirements. In both scenarios, the setup is insanely speedy and demands minimal coding skills. So let's get the ball rolling. To make things easy for you, we've included all the code, the example data, and this diagram file in a GitHub repository, which we've linked in the description of this video. Kicking off within the Google Cloud Console, we begin by setting up our cloud storage bucket. While the default settings should work like a charm, you can tweak them to appropriately align with your geographical region and the anticipated frequency of uploads and data access. We strongly advise maintaining public access prevention for security. Now, on to the exciting part, exploring different ways to import future CSV uploads into BigQuery. As a starting point, we need to establish a landing zone within BigQuery, also known as a dataset, which we'll dub as partner orders. Suppose we're continually receiving CSV files that house external orders intended for our analytic systems. Once we've created this dataset, we're ready to advance. It's time to outline the cloud functions approach for bringing our CSVs into BigQuery. This involves activating certain APIs if they're not already enabled. We can then opt for either the first or second generation of cloud functions. However, we have a slight inclination towards the latter, which employs EventArc as our trigger when a fresh file lands in our cloud storage bucket. For configuration, we'll pick the cloud storage option as our trigger, and for the event, finalized signifies that a new object has landed in the bucket. Now we select our freshly created bucket and authorize the necessary permissions. We'll keep our functions runtime, security, and network settings untouched. Since we're not dealing with extensive processing, but merely initiating a BigQuery import job, these settings are sufficient. The function we'll deploy is written in Python. It fetches the name of the bucket and the object from the trigger event, and then crafts and runs a BigQuery load job. The load job draws data from the CSV file utilizing an auto-detected schema. The dataset and table names hardwired into the function should be modified to match your setup. While our function is still under creation, let's reflect on a few takeaways. For our cloud function, the time delay for importing data into BigQuery is essentially zero. Code complexity is kept at a minimum, and versatility is tremendously high, especially because we're leveraging Python, which leaves room for transformations and additional logical manipulations pre-import. In the grand finale, we'll put our cloud function to the test. Find your bucket on the cloud storage page and upload a partner orders CSV file. You should soon spot your data making its grand entrance into BigQuery. The job has nicely inferred the schema from the CSV file, and if we preview it, we can see that the data is now ready in BigQuery. However, note that if we continue to upload files, the program will keep recreating this table. So you may need to adjust the logic if you need to, for example, append or create new tables each time. Now let's move on to the second option, which is the data transfer service. We will enable that API if it is not already enabled. Before we actually create the transfer job, we'll delete our existing table so we can create a fresh one with our transfer job. In this transfer, we're going to select the Google Cloud Storage option. Note that we have a sort of cron specification for how often we want to run this job, but it can only run at the maximum every 15 minutes. As before, you need to consider whether you want to append or overwrite your data. There are some additional configuration options available. This option doesn't require any coding at all. The configurability is provided in the GUI. We will specify that we want to skip the header row. Checking our job, we'll see a crucial detail and a difference between our cloud functions and data transfer that we actually need to have the table set up beforehand. We want to highlight this difference. You need to create the table with the correct schema before it will work. To illustrate, we'll bring in the file manually, and then we'll remove all the data from it. This will give us a blank slate for our job. Back in our transfer job, if we manually trigger a run and then return back, we see that the operation was successfully executed. In BigQuery, we can again see that data showing up. Next, let's consider an additional metric, schema and table pre-work. With Cloud Functions, we don't really need to do any pre-work, but the transfer service does require it, as we've discovered and highlighted. Do note that because this process is not triggered upon the creation of cloud storage objects, there will be a delay between our file uploads and the data showing up in BigQuery. However, it is a virtually code-free option, and its configurability is pretty good, albeit not as good as Cloud Functions since we are working within the constraints of a GUI. Summing up, Cloud Functions would typically win in most aspects if you're comfortable with writing about a dozen or two lines of Python. But if you want a totally code-free solution, then the transfer service might be best for you. We hope that this video was helpful, and we'll be monitoring the comment section for any questions. Thank you for watching, and please enjoy responsibly.